Okay guys, let's take a look at today's lesson. Today's this unit on differential equations and slope fields, volume, area marks the last part of the AB curriculum. We've talked about differential equations before, and I've tried to, what does it mean to solve a differential equation? We've talked about that before, right? What does it mean to solve a differential equation? It means you get what? Close. What do you get when you solve a differential equation? What are you looking for? The actual original equation, right? You're looking for the original equation, and we have done a little bit of that before. In college, there's an entire course or courses devoted to differential equations. We will just be looking at, the most basic differential equations in here. So first of all, let's remind ourselves, what does it mean to be a differential equation? It's basically an equation that has derivatives in it. So we've been looking at differential equations for months. The order of a differential equation is the order of the highest derivative. So in this example right here, in this particular example, the highest order derivative is a first derivative, first power. So this is called a first order differential equation. If that had, y double prime, then it'd be a second order differential equation. To be a solution, a function is a solution of a differential equation, and this is pretty much common sense. To be a solution, it's going to satisfy the equation. So for example, if we decide, let's say this is one of the solutions to this particular equation, we would take the derivative of it, sub it in, see if it satisfies it. That's basically what that means, and we're going to work an example like that to see if a function is a solution to the differential equation. Another vocabulary word, equilibrium solution. Sometimes they ask for the equilibrium solution, and that basically is just the solution that involves just a constant y equals 5, or p equals 0, whatever it happens to be. Separable equations, separable differential equations. That is a technique for solving differential equations. Okay, they're called separable differential equations, and we'll be working with those. What that means is we can separate the variables. We can get the x's on one side and the y's on the other. That's what that means. And if you have a separable differential equation, these are the steps that you take to solve it. Basically, the first thing that you would do is you would rewrite the equation by moving all the y's and the dy to one side and all the x's and the dx to the other side. Then step 2 would be to integrate both sides, and step 3 would be to solve for y if possible. We've been doing differential equations for months. It would have already been separated for you. Sure. Yeah, we've been doing that for months. Separable differential equations. Okay? I just haven't called them separable differential equations, but you have solved differential equations already. Basically, when you integrate an integrated derivative, you're solving the differential equation. All right. So, any questions before we move on to the examples? We okay? All right. So let's take a look at our examples. Okay. So the first one asks us if y equals e to the negative t is a solution to the differential equation. First of all, what order is that differential equation? It's a second order differential equation because it has a second derivative, right? We're good with that. The highest derivative tells us the order of the equation. So this is a second order differential equation, and all they're asking is this function, is this y equals a solution? So how are we going to be able to tell if it's a solution? Yeah, we're going to find, we need to find the first derivative and the second derivative and then sub them in, right? See if it solves it. That's what we want to do. We want to see if this solves. So I'm going to go over here to the side, and I'm going to find the first derivative. And hopefully we recall the derivative of e to the box is e to the box times the derivative of the box. I'm sure we all remember that. So this would be negative e to the negative t. And then my y double prime, again, same rule. I'm going to get e to the negative t. So let's go ahead and substitute those in. So we're going to replace y double prime with e to the negative t plus 2 times y prime is negative e to the negative t. And then y, excuse me, is e to the negative t. Okay, so let's simplify that. See, I have 2 negative ones and 2 positive ones. Certainly that does work. So 0 equals 0. So yes, it is a solution. And that's basically all that type of problem involves is it a solution or not? You calculate the derivatives that you need, sub it in, and see if it works or not. Pretty straightforward. We okay with that? Okay. The second one, given the differential equation, solve for y as a function of x. So let's talk about the instructions and all the different things it could say. It could just say solve the differential equation. And you're going to get the same answer because when you're done, you're supposed to solve for y, if you can. And many times for us, we will be able to. So notice how we have, it's all mixed up. The y's and the x's are all mixed up. So first thing we're going to have to do, step 1 was to separate them. Now, I need to be sure I make this point because every year I have a little bit of an issue with this. The differential, remember from that lesson from differentials, this is dy is a differential, dx is a differential. The differential cannot be in the denominator. Okay, no, period. No denominator for differential. They have to be whole. They have to be in the numerator. So I would not be able to leave this dx here and move the x over with it. And I would not, and move the dy to the bottom. That is not okay. Are you with me? The dx and the dy have to be in the numerator, just to keep that in mind. So, knowing that the dy and the dx have to be in the numerator, my choice really is I'm going to move the dx over here and the y over here. So that's y dy equals 2x dx. So step 1 is, again, separate them. Get the y's and the dy on one side and the x's and the dx on the other. Alright, so step 2 tells us to integrate both sides. Now I know last semester when we were doing integrals and we had more than one integral in equation, some of us got a little bit upset about the c's. Okay? Alright, so there's only going to be one c. Alright, we're just going to have one c in this one equation. And since we have to solve for y anyway, I typically will put the c with the x because we have to solve for y anyway. So it just is easier, I think. Now you can put the c on either side you want, but I would advise you probably the easiest thing to do is to put it on the side with the x. Alright, so let's integrate. So the integral of y, remember we do our reversal power rule just to kind of get those memories flowing, right? After a couple weeks off. So we add 1 and get a 2, divide, so it's be 1/2 y squared. Okay, we integrate the other side, so we get x squared plus c. Now there's a lot of different places that you can find the c, and when we get to word problems, this doesn't always hold true, but I will tell you what I like to do in the vast majority of the problems is as soon as the c appears to solve for it. It just makes life easier for me. There's a certain strange instance where it doesn't, but that's with the word problems, and we'll get to that later. But for the vast majority of the time, it just makes my life easier to go ahead and deal with the c right now before I solve for y. So let's just find c. We're told that when x is 1, y is negative 3. So let's go ahead and sub that in. So let's see, negative 3 squared. What is that? That would be 9. So 9/2 equals 1 plus c. So c is 7/2. Okay, once we have that c, we substitute it back in. So I have 1/2 y squared equals x squared plus 7/2. Now my goal is to solve for y. That's just what we're always going to do. That's our default, solve for y. So I need to move the half, so I multiply through by 2. And then to get rid of the squared, I would square root both sides. Now this is not the answer yet. Okay, this is where it gets tricky. And they will try to trick you. So let's be really specific about this. Right here, I have two functions. I have the positive one and the negative one. Right, I have two. I need to choose, now we want the specific solution that goes with this initial condition. Okay, that's what we're looking. We want the solution that goes with that initial condition. So that initial condition has a negative y. Which one of these options is going to give me a negative y? The negative one. All right, so the negative one is my solution, not both and not the positive one. So please be careful about that. We want to pick the one that goes with the initial condition that we're given. That's the one that we choose. And so this is our solution. Okay, the negative one, not both and not the positive. Does that make sense? We want it, and again, that's about as tricky as that gets with that little, if it turns out to be a radical, a plus minus radical, that it causes lots of students problems. So that's why I'm making sure to point it out, that we need to be sure to choose the one that matches the initial condition. Okay, we okay with that? Okay. All right, this last example, y prime equals x squared square root of y. Now, the first thing that I would do is I would rewrite the y prime to be dy dx, because it just makes more sense to me. I can see it. You certainly don't have to, but I would just go ahead and rewrite it. Dy dx equals x squared square root of y. And that's what I would do. And now, keeping in mind, the differentials have to stay in the numerator, not allowed to be in the denominator. I'm going to move the dx over, which means I'm going to have to move the square root of y. So dy over square root of y equals x squared dx. Alright, so that's step one. We separated the differential equation. Step two, we integrate both sides. Now the square root of y, I'm just going to come up here, just a little bit of scratch notes, I guess. That actually would be y to the negative 1/2, right, when we integrate, just so we can see it. So if I integrate y to the negative 1/2, I'd add 1, right, I get 1/2. I divide by 1/2, which is multiplying by 2. So this is going to give me 2y to the 1/2 equals, so I integrate the x squared, and I get 1/3 x cubed plus c. Again, as soon as the c appears, I like to solve for it. Just makes my life easier. So we take our initial condition, when x is 3, y is 4, and we sub it in. So 2 square root of 4 equals 1/3 times 3 cubed plus c. Let's see, 3 cubed is 27. 27 divided by 3 is 9. And then, what is that? 4. So c is going to be a negative 5. Okay, we okay with that? So now sub that back in. So I have 2y to the 1/2 equals 1/3 x cubed minus 5. Alright, so the last step is to solve for y. So I'm going to get rid of the 2 by multiplying through by 1/2. So y to the 1/2 equals 1/6 x cubed minus 5/2. And since that's raised to the half power, what am I going to do? I'm going to square both sides. So I get y equals 1/6 x cubed minus 5/2 squared. Now, this is not the answer that they would give you in a multiple choice. Okay, so there's actually one more step. Say this were a 4-point problem that on a quiz or a test, you would get 3 points up to here. The final point would be the simplification portion. Now, they want it so it's pretty. It needs to be pretty, right? They're going to factor out the fraction here. That's what they're going to do. So that's what we're going to do. We're going to practice it. It's good for you. I know we're looking, what? Yes, because I don't want, so let's finish and I'll explain why. So I want to factor the fraction out. What fraction am I going to factor out? The 1/6, right? I factor out the 1/6. Now keep in mind it's still underneath the squared. I'm not pulling that out yet. So, and this is a little bit of fancy footwork here, but I like to think of it as, what would I multiply a 1/6 by to get 5/2? Or maybe that's even more difficult. 15. Or the other way to think about it is I'm really dividing by 1/6. Dividing by 1/6 is what I'm doing. I'm taking out 1/6, which is the same thing as multiplying by 6. You with me? So then they would release this from the squared. So this would be y equals 1/36. Okay. So the reason that we're doing this is because on the AP test, very likely this would be a multiple choice question, and you'd get here, and you wouldn't have that answer choice, and you might think, oh my gosh, I've done something wrong. No, you haven't done anything wrong. In fact, you have the perfect answer. They just factored. So that's why I want you to practice. We're going to practice putting it in this form so that you will recognize it on the AP test. Does that make sense? That's why. So I would typically put a point with this. And just so that you know, the part in the parentheses, they make whole numbers. That's what they like, whole numbers. So if you've got a fraction in here, you need to factor it out. Okay? Just so that you're aware. All right, how are we doing? Good?